Welcome to the next session of ANSYS APDL. In this session, we are taking up this numerical for getting the solution for its SFD and BMD. This is a simply supported beam with an overhang to the right. It is subjected to uniformly distributed load and also a point load. So we will start structural, preprocessor, element type, add, edit, delete, add, beam, 2 node, Then I'll go to material properties, material models, structural, linear, elastic, isotropic. I'll give the value of Young's modulus as 2E5 and Poisson's ratio as 0.3. Next, I'll go to sections, beam, common sections. Let me give the breadth as 50 and the height as 50. Next, I'll go to modeling, create key points in active CS. The first node is at 0, 0. The second node, as we can see in the diagram, B, is at a distance of 1 meter from A. So this will be 1000. Then I'll apply the value for the third node, that is C. It is at a distance of 2 meter from A, which means it will be 2000. Then I'll apply for the fourth node, D. It is at a distance of 4 meter from A. So this is 4000 mm. And the last point, E, is at a distance of 5 meter from A. So this will be 5000. So I got all the 5 nodes. Then I will go to lines, straight line. I'll click on 2 nodes at a time to draw a line. Then I'll go to meshing, size controls, manual size, global size. I'll give the number of element divisions as 10. Then I'll go to mesh, lines, pick all. So my meshing is done. Then I'll go to plot controls, numbering, and I want to see the element number. I can see all the element numbers here now. Then I'll go to loads, define loads, apply, structural, displacement on key point. So first I'll apply the displacement, that is at A and D. There are hinge and roller respectively. So I'll apply those two. At A, it is hinge. So I'll select UX, UY, UZ, rotation about X and Y. All will be set to 0. Then I'll have to apply at point D. So it is here at 30. It is a roller, so only UY is 0. It is done. Next, I will apply the force, which I can see at this node B of 5 kilonewton along the y-axis. So at node B, Fy is minus 5000. Then I'll apply uniformly distributed load between CD and DE. The value is 2 kilonewton per meter, which means it is 2 Newton per mm. So I will go to pressure and I will select on beam. I'll start with this portion. This is CD portion, as you can see here. The load key value is 2 because I'm applying along the y-axis. The value is 2 Newton per mm. I also have to apply on this section on beam. It's better that you apply it separately to avoid any error. If you want, you can apply together, but I would prefer applying it separately to avoid any type of error in the analysis part. So now I'll go to solution, solve, current LS, close. So this completes the solution. Next I'll go to general post processing. Here I'll first go to element table, define table, because I ultimately want to draw the SFD and BMD. I'll choose by sequence number 3, 6, 16 and 19. These 4 I want to select. Close. I'll go to plot results, deform shape. I want to see the deformation in this beam. Then I'll go to contour plot, nodal solution, degree of freedom, displacement vector sum. Okay, so this is how the deformation looks like. Also, if I want to see the stress over the beam, I can see that. I'll choose 1 ANSYS stress. Okay, this is my stress over the beam. Now, if I want to draw the SFD and BMD, I'll go to line element resolution. I'll choose 3 and 16. This is for the BMD. I can check the solution. It is exactly the same. The maximum value over here is 4.5 kilonewton meter. So let me check here, this color red. Maximum value over here, now this is given again in Newton mm. So when I have to convert it into kilonewton meter, I have to divide by 10 raised to 6. So this value approximately becomes 4.47. So it's close. And this value in blue, if I see, this will be 0.9, minus 0.9. So I can see here, this is minus 1. So again, it's a close value. So my BMD obtained is correct. Next, I'll go for SFD. So I have to choose 6 and 19 as the two numbers. Okay, so this is how it looks like. Let's check with the solution. Okay, it's approximately the same. Now let's check the values. Here, this blue color over here, it shows, okay, it's 4500 Newton, which means it is minus 4.5 kilonewton. Let's check here. It's exactly the same. Now the direction is reversed because of the assumption of which direction you are taking. For example, if you take upward forces to the left of section, if you recollect the procedure for solving, the sign convention for solving of SF for particular points on the beam, then you would recollect that we have used upward direction as positive. In ANSYS, upward direction is negative. So that's why it's just reverse of what we have got as a solution. Now here, the constant value is minus 0.5 kilonewton. So let's check here. This color is green. It is correct. Minus 0.5. Then again, this yellow color over here, I can see. So this value is again 4.5. So let's see here, this red color. I can see it is 4.3. It's close again. And this value down, here I can see this 2 kilonewton. Let's check here. This is blue. So this is the blue color, and here I can see it is 2544, which means it's 2.5. So again, it's close. So you're getting a close answer. It may not be exactly the same value. As I've told you, ANSYS is the approximate method. If you want to see the animated result, you can go to plot controls, animate, deform shape. I want to see the deform plus undeformed shape. Okay. So this is how I can see the deformation in the beam. So I hope you have understood how to solve this numerical and how to view its result, and also how to match it with the numerical solution, which is very important to prove that the answer that we have got is correct through ANSYS. So in the next session, we will solve another numerical. See you in the next session. Thank you.